Hey everybody, this is the introduction to derivatives. So this gives you the very basics and the beginnings of a derivative. So if you've never heard of a derivative, this is a great place to start. So derivatives, in short, are things that help you find slope. Likely, up to this point in your math career, you've only ever found slope of a straight line. And when you did it, you had to do it with two different points. But now, with derivatives, not only can you find the slope using just one point, you can find the slope at any point on a curve. So first of all, it's important to link in your mind the idea that derivatives find slope. A derivative is really an equation that tells you the slope of another equation. Now I have notation here for you. There are two guys credited with calculus. One is Gottfried Leibniz and the other is Isaac Newton. Leibniz preferred the first notation, where the original was y and the derivative would be dy over dx, and that means the derivative of y with respect to x, but it's usually just read dy dx or dy over dx, while Newton preferred the prime. Those things that look like apostrophes are said prime, so the original would be y, the derivative would be y prime. The original would be f of x, the derivative would be f prime of x. So if you look in the upper right corner, let's just focus on this part for a minute. This is called the power rule for functions, and it's how to deal with exponents. So if you have a function ax to the n, then to take the derivative you do two things. You multiply by the exponent. So if you notice, we just took the exponent and multiplied it by the coefficient, so multiplied it down, and then subtracted 1 from the exponent. So multiply by the exponent, then subtract 1 from the exponent. So if you look at this first example where I have 4, if you think about it, what we really have for the exponent here is 0, because there are no x's at all. Well then, if you multiply by the exponent, 0 times 4 is 0. Well, if you subtract 1, it doesn't matter, because, it's just 0. You can write this if you want, but 0 times anything is just 0. And that should make sense, because if you think about the original function there, 4 would just create a horizontal line, and the slope of a horizontal line is 0. Therefore, the derivative is also 0. Okay, now if we look at this next example, y equals negative 2x plus 5. Well, when we're adding, we can take them separately. So we'll look at the 2x first, and that's 2x to the first. So I multiply by 1, and I get negative 2. And then it becomes x to the 0, which is just 1, so it just goes away. There are no x's, in other words, if it's x to the 0. And then 5, the derivative is going to be 0 for the same reason 4 was 0. If it's just a constant, the derivative is 0 because the slope of a constant is 0. And again, if you remember what you've learned about slope so far, that should make sense, because this is a straight line and the slope would just be the coefficient of x, and sure enough, that's our derivative. So where it gets a little different is on ones like x cubed. This is where our calculus really comes in. We take the exponent and we multiply it down. So we get 3x, and then we subtract 1 from this original exponent, and we get squared. 3x squared. So multiply by the exponent, then subtract 1 from the exponent. Okay, over here on the right we have the cube root of x. Now what we need to do first is rewrite this so it has an exponent. So it becomes x to the 1/3, because that's equivalent. Now notice I haven't taken a derivative, I'm just rewriting it to make it easier to take the derivative. So now I can multiply by the exponent, get 1/3, then subtract 1 from the exponent. 1/3 minus 1 is negative 2/3. And for this last example, we have 1 over x squared. We cannot take the derivative of a denominator, so we have to rewrite it. We have to rewrite this as x to the negative 2. So I brought the x squared up top and I rewrote it as x to the negative 2. So now we multiply by negative 2 and subtract 1 from the exponent. Now we move the x down and we get negative 2 over x cubed. Okay, now again, when we're adding or subtracting, we can just treat each piece separately. So for this one, we'll just look at x cubed, negative 4x, and 5 all separately. So for x cubed, we multiply by the exponent, subtract 1 from the exponent. That negative 4x is just going to turn into negative 4 because the exponent is 1, so you multiply by 1, and subtract 1 from the exponent, which will just make the x disappear. And the derivative of 5 is 0. The derivative of any number all by itself is 0. Okay, in this next example, we have negative x to the fourth over 2 plus 3x cubed minus 2x. You do not have to rewrite this, but I usually find that people find it helpful, instead of writing it as negative x to the fourth over 2, to write it as negative 1/2 x to the fourth. Because dividing by 2 is the same thing as multiplying by 1/2. So now I can take the derivative. I multiply by the exponent, the 4, and get negative 2, and then subtract 1 from the exponent. I multiply 3 by 3 and get 9, and subtract 1 from the exponent. Negative 2x just becomes negative 2 because you're just multiplying by the 1, and then the x goes away. Okay, again, this is a type where you'll have to rewrite it. So we have 2 over x. This is really x to the first. So when I rewrite it, it's 2x to the negative 1. Again, that's just rewriting it. That's not taking the derivative. So now when I take the derivative, I multiply by negative 1 and subtract 1 from the exponent. And you can leave it just like that, or you can rewrite it where you put the x to the negative 2 down below. Either way is fine with me. Just make sure you know what's preferred. The main issue for those of you in my class is just that you need to recognize that both of those are the same thing. So if it's a multiple choice question and they show you this, but your answer was this, you just need to know that those two are equivalent. That's my only concern. Okay, this next one we get to rewrite. This is 2 times the cube root of x squared on the bottom. So it'll be 2 times x to the 2/3. So remember, the numerator is your power, the denominator is your root. Now I can bring that up as 1/2 x to the negative 2/3. Notice I did not bring this coefficient up top. It stays. It's not part of the exponent. That 2/3 does not apply to it, so I can't move it up. It's just the x part that moves up. So now I can take the derivative, do negative 2/3 times 1/2, then subtract 1 from the exponent, and you get that. There are also 2 trig rules you need to know. The first is that the derivative of sine is cosine, and the derivative of cosine is negative sine. And just in case you're unfamiliar, this d over dx just means derivative. We're taking the derivative of sine x. We're taking the derivative of cosine x. So the derivative of sine is cosine. The derivative of cosine is negative sine. Now the derivative of 2x squared would be 4x. Multiply by the 2, subtract 1 from the exponent. Now here we have negative 3 cosine x. Now the derivative of cosine is negative sine, so I'm going to have positive 3 sine x. It turns positive because the derivative of cosine is negative, so then I have 2 negatives. And then the 3 just stays. The coefficient just stays. Now the derivative of 4 sine x will be 4 cosine x, because the derivative of sine is simply cosine. Okay, there's some examples you can look at if you're in my course. Other than that, good luck.